Acids can be characterized as strong or weak. Strong acids completely ionize. And what that means, completely ionize, is that the acid completely donates all of its protons to water when it's dissolved in water. So hydrochloric acid is one of about a handful of acids that are considered to be strong, that completely ionize. When we dissolve HCl in water, all of the protons from HCl are donated to water. So after we dissolve HCl, there's no more HCl, really. What we have is hydronium and chloride. So if we start off with 0.1 molar of hydrochloric acid, afterwards we'll have 0.1 molar of hydronium and 0.1 molar of chloride. We have ions. Now weak acids only partially dissociate. So for example, let's look at acetic acid, which is a carboxylic acid. It's found in vinegar, and although it does have an acidic proton, this hydrogen bonded to the oxygen, it doesn't ionize very much. Less than 10% of the acidic hydrogens actually leave acetic acid. So if we look on this slide, we see on the very top here chemical reaction of acetic acid with water to form hydronium and acetate. So there is a double arrow here, and we always have that double arrow when we have a weak acid dissolving in water. And what that means, what that double arrow means, is that some of the protons from the acetic acid or whatever weak acid we're looking at will be donated to water. But on this right-hand side where we have the hydronium and the acetate, there will also be a transfer back from the hydronium to the acetate. So the hydronium will actually give the acetate the hydrogen back to go back to acetic acid. So this side, the right-hand side of the reaction where we have the ions, hydronium and acetate, is a very, very small part of this whole process. Mostly we have acetic acid that is still holding on to that acidic proton. Only a small amount of that acidic proton is donated to water. So this was what's known as partial ionization. And just as a review of previous content, the conjugate base of acetic acid is acetate. It has one less hydrogen and a charge that is more negative by 1. And here's our base, water, and on the other side is its conjugate acid, hydronium. And the conjugate acid has one more hydrogen and a charge that is more positive than by 1. So weak acids partially dissociate to form hydronium and the conjugate base. Strong acids completely dissociate to form hydronium and the conjugate base.